I am recording, and I'm just gonna make a full recording of a walkthrough of the Webaverse networking system. While we are going to be changing and fixing some stuff, it's not going to change a whole lot from this like base theory, and this might be a really good reference to have as we code it later. So, okay, we're doing this again. If I drop off, I have the voice chat for this Discord room open. You can message me or something, and I'll try and notice. Okay. Wow, we're gonna start over. Fun. We're gonna start at universe.js. Well, actually, let's start from the scene select. So, in my scene menu, this is the place where that corresponds to this little object up here, and this allows me to change scenes, and it also allows me to go to multiplayer. And I can go to multiplayer by pressing this dumb little button, and then go into one of the scenes. So that's called the scene select. And you can see when I create a room, which I can do with like this create room, or I join a room. I'll just create one. Why not? That calls this function, which does some basic React stuff, but mainly it's calling this universe.pushURL. And this universe.pushURL is then passing in a new URL component and joining an actual world. Does some push state, blah blah blah, handle URL update, and that calls this dot enter world, which does what it says in the box. I'll go there. First, it disconnects the room if we were already in a room. Then it freezes the player, pauses physics, and then it loads the next scene, and either calls connect state if it is not a multiplayer session. If it's not a room, there's no room reference, it's just a regular like scene, then call connect state and load the world, which is all this stuff here, create a bunch of and if it does have a room, then it is a multiplayer session, and we'll get the room URL and then we'll connect to it. So what we're really interested in for the multiplayer stuff is this connect room. So we have connect state. This is our single player state connection. This is where when we connect to Webaverse, like start the app, we want to start binding certain things to state so that the application state is shared around the whole app. And that includes information about our players, about our world, and about our local player specifically. So as we go through here, we have a players manager.bind state. This is going to connect and start listening for changes to our local player, which probably might not be much in the case of the single player instance, but will matter more in networking, because it also handles the case of observing what happens when remote players join, when new players join our world, basically. Then we are going to get a reference to the apps in our world that were loaded when we connected the state, and we're going to bind the world to those apps. I have made a function to show what that looks like, but I'll get into that in a second. So binding the state of the world to the app says, hey, I have an app manager. The world and all players have an app manager on them. The app manager manages the apps, which could be like a avatar or a sword on a player, or it could be a pet in the world just standing there, or anything really. Every app is referenced by an app manager, and no apps are just dangling out without an app manager referencing. So the connect state is our single player stuff, but what's really more interesting is our multiplayer sort of loop. So the user comes, they press join multiplayer room, or they just go directly to the link. It calls connect room, and this is we're going to set up all the multiplayer state right here before we start the game loop. First we wait for physics to happen so that we don't get any race bugs starting up like a character controller. Then we're going to create an instance for WSRTC, new WSRTC. And WSRTC is the network transport library for Webaverse. It's very simple. It's just one. I'll just go to it because it's worth going to. It's basically one JavaScript. Well, it's got a bunch of stuff for codecs and stuff, but basically wsrtc.js. And there's some stuff here. The long and short of it is that it gets stuff through WebSockets. It applies it to the CRDT store, and then any changes that happen from the server or from other clients then get sent back to other clients. So it is just a very basic WebSockets network transport. It's not a lot of code. The main thing that makes WSRTC different than just WS, just WebSockets, is that it does handle the audio codec handling that you would expect from WebRTC. It uses web codecs and audio codecs to compress the audio on the way out. So we need to create a new instance of WSRTC, and we're going to pass it our state object, which we've created here. We've probably created a new state object. We said, hey, we're going to create a new transport, pass in our state, and now start making that state that we have locally the same as the state on the server. So the other key thing here, I went over this before, but I'll go over it again, is ZJS. So ZJS is a Webaverse version of YJS. It's at ZJS. It is very similar to YJS and uses the same API, but it is made to work with real-time games and high updates, and so it generates less garbage and is just more efficient for that purpose, and at the cost of some features in edge cases. YJS is a very popular framework to handle CRDTs. CRDT stands for Conflict-Free Replication Data Type. The goal of it is, if I move left and you move right, can we make sure that that data is sent at some point is made to guarantee that you see that I moved left and that I see that you moved right. Now, if I move left and you move right, and then somebody else comes along and moves both of us, and we all do this at the same time, how do we determine where we actually are? And that's a complex algorithm, and so instead of writing a whole thing, we use a existing CRDT framework to do the actual conflict resolution and say, well, you're actually here. And then the other part of conflict resolution is what's called eventual consistency. So right now we don't agree on the exact number of where you are, but eventually we will. And so YJS handles all of the work of making sure that things get to the final state, and that final state is fairly quickly replicated so that everybody sees the same thing. So when you're building a Webaverse is client authoritative. A game like Overwatch is server authoritative. So you're sending input with WASD, it's doing some calculations, and then telling you where your player is. On Webaverse, you're moving your player and then telling the server where your player is, and then it is propagating that information to other people because you have control and authority over your player object. And this is fairly common in certain kinds of games, but that's a whole other topic on why that's complex, why you would do one over the other. Just know that in Webaverse, we say, hey, my player moves forward. I actually show my local player moving forward. I make my player move forward, and then I send a message out through WSRTC to the other players, which changes the store, our ZJS CRDT store, and then emits change events to the other players of how it changed. I don't know if that makes any sense, but we'll unwind it a bit. I know it's a lot. So we make a web transport with WSRTC, and now we just have this object. We can get it kind of anywhere in our app, and it's a singleton, and you can get it from universe.wsrtc. We create an open event so that when we initialize WSRTC, it's going to say it's going to go and connect to the server, and then when that connection opens, we want to call this code that's inside of this open event. So, cool, we've opened a connection to the server. Well, the first thing we want to do is we want to bind our apps. In my, let's see, I'm back in Webaverse. And I just want to see, well, what does that actually look like? I have my ZJS doc, and I've received my changes since I've connected from the server. I look in the apps, and I have 5 apps. And these apps are bound, right? There's an app in this world here. I can see there's like this treehouse 3D model, and then that corresponds to this treehouse right here, which has an instance ID. It has a position in quaternion, which is like a way of storing rotation. And it's just here bound in the world. And what's cool, I could actually move it. Whoa. Yeah, that wasn't the best experience, but let me get over here. I can move it. Whoa. Okay. Theoretically, I can move it. And that will actually update in the world for everybody else. So if I drop a sword, then the sword is bound into the world. Everyone else sees the sword appear. And then if I, say, move the sword, can I do that? Should be able to. It won't let me. Weird. I think I can't move grabbables. But if I grab the sword, it'll see it update. But theoretically, you should also be able to like move things around and you can see them move around. Because they are bound apps, right? They're bound to the document, they're bound to the store, but they're also represented in the world. So I've called my open function. I've grabbed my apps array, which are those 5 apps that I received when I joined, and I'm going to use that later. Then I bind my players. So to bind the state of the local players, well, not much really needs to happen for the local player. The local player is the local player, right? If I press W, the player moves forward, it updates. Not much actually happens. You can see here, I have this, I call bind state. And all bind state does for the players is it's going to create an observer function. And that observer says, anytime that a player joins or leaves, do some code, right? That's like essentially what an observer is anytime this object changes, I want you to respond to those change events. So I'm going to open up this player's observer function, which gets called every time the player's array changes. And I'm going to see that I have added, deleted, delta, and keys. We're not really using the delta, but that's very helpful. You can actually know how much changed by if you wanted to. We are using the added and deleted functions. So, I don't really need to know how much the array changed by. I need to know, did a player join or did a player leave? And so if a player joined and they were added to this array, great, well now I can handle that. And I have, we can skip this for lib, doesn't do much. Well, some of it does. So for each item added, I want to get the player ID. And if it's not my local player, I probably don't even need this, right? I should probably just be able to do that, but we'll leave it there for now. If it's not the local player, I want to create a new remote player. And so how do new remote players actually join and get set up in the world and added to state? It happens right here. The local player joins, they bind their player ID when they connect to the world to the player's manager. Then that sends out a message to everyone else, hey, I joined. That fires this player's observer function, which says, okay, you joined, well, what's your player ID? Well, I'll get it from the player map, right? This player map is the map of information about the new player who just joined. Okay, so I've got my player ID. Oh shit, did my shit crash? Okay, we should wait for that. 1 second. My Discord has completely crashed, and I want to continue streaming to the people. So I will have to reopen it. Let's see. That is just so terribly frustrating. Well, maybe I can just... yeah.
Hey.
That is just the most frustrating thing. But I caught it, and I noticed...
Recording still, though?
I am recording still. But I stopped immediately. I didn't miss anything. Don't worry. Jesus. Is this boring? Is this helpful or illuminating or interesting at all?
It's interesting.
Cool.
Because, if you want multiplayer in other places, this is a solution I haven't really seen in too many other apps. They usually use the WebRTC, instead.
Yeah, this is a very different thing. What's cool about the CRDT and stuff is not immediately obvious, but once you realize like everything is just components which are also synced, so an app is like got a bunch of components on it, then you don't need all of these different functions for every single component handler. You're just like, yeah, just sync, you press this, you just sync, all the data is synced. I don't know what to tell you. And then you respond to the sync changes. So, okay, so picking up where I left off, we have we're binding the state of the players, right? And what we care about is if a player joined, create a new remote player, and if a player left, destroy the remote player and remove it from the state. That's pretty much it. That's all the player's manager does, actually. Yeah, literally just like those two things, and then you can also say, well, which players are here right now, and it'll give you the array. That's all it does. But we bind it so that now we can start handling remote players joining and leaving. Then we bind our world. So in our in our Webaverse session here, we have this apps object, and this apps object, this apps, corresponds to apps map name. Apps map name is apps, right? Let's put that there for a second. And so the apps array is all of the objects that are in the world are under this array called apps, which I just showed you. And we want to bind that to the world app manager. So all the apps that are just out there in the world, we're going to bind to the world. What that means is when they change, the world's app manager will handle those changes, which could be like a player picks up the app, right? So then the world needs to tell everybody, hey, that is not in the world anymore. It's on that player now. And so when you hand something to someone else, you have to think about like, well, who is taking care of that functionality? Am I doing the like, okay, well, I do the handoff, so I'm also getting responsible for the cleanup and the changes and telling everybody? Or do I hand it off and then the person who got it, it's like, okay, well, I received it, so I'll do all the cleanup and the changes and everybody. And that's something that we will have to figure out. But the world basically is responsible for that, specifically the app manager on the world. So world has an app manager. Players also have an app manager, and they both bind application state to their app manager, but they have different app state. The world has like a treehouse in it, and maybe like a sword and a fox. The player, well, when they land, the player has, let's see what their state is. So we can go to the doc, and we can see that the app state generally is there's 6 apps. There's a sword and a treehouse and some stuff in here. And if we look at the player state, the player also has some apps on them, but all they have is their avatar. So they own apps the same way. The apps are synced the same way. And the world and players both have an app manager. and local players and remote players all have app managers. So when we bind the state of the app manager, what we're doing is saying, let's listen for changes to those apps and then respond to them. Or if we are the owner of those apps, let's be the ones who actually publish the changes. So I'm going to look at the, well, I think that we should go over characters first, and we'll go over application state. So I've connected to this session. I've got it, joining multiplayer. I have bound my player. I started sending player updates from my player, rotation and transform and avatar and stuff. I started receiving information from other players. Now I've bound my instance of the world to the app state of the server, so that the world is saying, okay, cool, I've got some new apps, I'll start adding them to the scene and doing stuff with them. And if anything happens in my local world, that will also then go back out and update the server. Then I'm calling, the next thing that happens is once we've opened the connection with our WebSocket transport, we're going to call it calls the init function. So it says, hey, we're open, great, now I'm going to send init, I'm going to pass you some initial data to kind of get going. There's actually not any data that we're handling in the init right now. It is getting passed, we're just not handling it. But we do use it to then say, well, now we've finally initialized, so let's bind the state of the local player. So if you're in single player in Webaverse and you want to go to multiplayer, it would be really nice if that was a seamless experience and we didn't have to destroy your player and then create your player again. I think that in this current build it's broken, but if I leave, you see that my player didn't, actually worked great. My player didn't destroy. Everything else around my player changed. My player object stayed in the scene and stayed bound. And if I were to have, well, except for that, and if I were to have weapons and stuff on, all of my gear would stay with me. So I'm actually detaching my player and then changing the scene and putting my player back. So conversely, when we connect to a new scene, we want to kind of bind our player last so that they stay kind of with as much of their state as possible, so we don't have to have that hang up happen until we get new state from the world. So say, okay, great, we've bound everything, we've bound the world, now let's start sending our local players' data out and receive any changes back in. Then the last thing here for the initialization of multiplayer is audio. And that's just saying, hey, we got an audio message in, let's see who the player is that it's for, and then we'll send that audio buffer data to that player so that it plays spatially out of that player's mouth. And what's cool about Webaverse is that if you look at individual players,
hello.
Well,
this is a test.
We should make sure that's working because their player mouths should actually move. Probably if yeah, there you go. I can do it with my own mouth. You can see if I'm talking, the mouth of my player will move. And that's because it's being handled, and this will happen in remote, like with a remote player too. It's actually will be sent over the network and handled the same way as my own microphone. And so that's happening from this code right here. So that's the whole universe connection. There's three other things that I need to cover. I need to cover how the character controller and character controller state work. I need to cover the app manager and how app state works. And then I need to cover Webaverse.js and the application loop of the Webaverse app. I think that that's the best place to start because it's fairly straightforward. So inside of any game engine, you have an update loop. Essentially what a game engine is a framework to build a complex update and render loop. And inside of there, you're going to have input, output, movement, physics, rendering, post-processing, all the other stuff you got to set up and tear down every frame. So Webaverse.js is where that core application loop happens. There's a lot going on in here, but all you really need to know is one function, which is start loop. Start loop starts the loop. Once the loop starts, it never ends. However, we can wait for loading of other things to start it, and we can also say like, oh, well, something is not started yet, so just ignore this frame if we want to. So render.setAnimationLoop. Render is a Three.js WebGL renderer object. The setAnimationLoop says take this animation function right here that we've created, which we'll look at in a second, and call it every frame. So inside of this animate function, we have an inner frame function, which is just wrapping that. And what are we doing here? Well, we're computing the time difference from the last frame, which we'll use in a bunch of stuff. Then we're going to simulate physics, both for the world and then for we'll update the physics on the local player. Then we're going to update the transform controls, which would be like grabbing and moving stuff, as well as the raycaster. What am I actually looking at? Then we update the game, which does like a bunch of different stuff. Updating internal game state and some input and output and actions and things. Then we update the avatar on the local player. And this would be like, is the avatar running? That's going to be based on their current velocity. Is the avatar's hair updated? Like that all gets updated in this update avatar loop here. We should update the remote player avatars and remote player stuff here, but currently we're not because that's in progress. Then we're updating the world. We're actually calling tick on the world, which sets the timestamp and frame information and then dispatches a frame event to the world. And anything else that is in the world which uses like says, hey, I need to get the frame information, gets it from this tick function. So if other apps are like, oh, I want to update every frame, then they would get called by this tick. Then we update our mobs, our HP, our quests, our particle systems, and that's like our basic game loop. And then we're going to get into updating our camera. You always update your camera last because the positions of everything need to be finalized before you render. Otherwise you can get stutter issues or race issues with the camera updating before the player or whatever. Then we clean up our input-output, you know, WASD stuff, make sure that's all clear for next frame. Then we actually push app updates, which says, hey, send out any transform updates for this app if it moved this frame to the network. Or push player updates, send out any player information from the local player if they moved this frame over the network. And then we set up our XR session if we have XR. And that is our frame setup. And then finally, after all of that stuff, we call render. So that's all the main setup loop, and then finally at the end we have this.render, which is itself wrapping this function right here. So getComposer gets the current post-processing effects composer that we're using. In Three.js, if you're just using bare Three.js, you would just call render. But if you want to compose a post-processing stack, have like depth of field and shadows and other things happening before it gets rendered, not shadows, but like screen space, reflections, and occlusion stuff, that all happens in the composer. And then the composer calls the Three.js render function. That way it can get a reference to its own layer stack. This is the function that actually renders things on screen, and that is the entire Webaverse loop. Set up the input, set up the output, get the new stuff, simulate the physics, send out the new send out the local stuff, and then render it. So we have two other sections we want to cover. First one is probably character controller. Okay, so the character controller is broken up into sort of three different class types that inherit from each other. The first is that we have a player base. And the player base inherits from Object3D, which means that it is an object which can be placed inside of a scene, in a scene hierarchy. It can be rendered, it can be moved. It has position and rotation and other important values. Inside of our player base, we're doing some, like the main thing that we're doing that's important is we create an app manager. All players, no matter what, have an app manager. We're setting an avatar to null because all players do have an avatar, and we're just going to initialize that so it's not undefined. And then we also have these functions for app add and app remove, which are, if we add an app to this character, then let's add it to the scene of the world. We'll handle it that way. And if it was removed and the character was not detached, then remove it from the scene. So we would detach a character in the case of changing from one world to another. We detach the player, and that way we don't remove the apps from, like, we don't take the sword off your back. But otherwise, if you remove a player, it would also remove all of their objects. On the other things on the base player are just like basic things for actions. Actions would be sitting, wearing, swinging, aiming, a lot of different things that players can have multiple actions at once. And actions are synced over the network. So all players have actions, and most things that happen when you press a button are actions. Also, all players have a voice pack. Voice pack is the gobbledy when they, like, hups when they jump, like, hup. Or if you talk to the voice pack and don't have a voice endpoint, it'll make gobbledy noise, like Sim's voice. And then we also have a voice endpoint, which is a real voice voiced by our voice server, which uses like AI to make text-to-speech. And then also all players can wear and unwear, and there's a bunch of stuff to handle wearing and unwearing physics and stuff like that. So all players inherit from player base. Makes sense. But then we have some things, some new kinds of players building on top of that. The state player adds state binding and everything around networking to the player base. So if you were just programming Webaverse and you're like, well, I don't really care, I just want like a player that stands and moves around, they might not need to be a state player or anything. You could probably just build from the player base. But for all local players and remote players, they are going to inherit from the state player class because they need to be able to bind their state, detach their state, bind observers to listen for actions over the network, change the avatar if the avatar stuff is changed over the network, etc. So that's all handled by the state player. State binding, unbinding, avatars, observing change events, that's all handled in the state player. However, some things are different between the local player and remote player, obviously. The main thing that's different is that local players, when you press W on your keyboard and it moves your character forward, wherever your character lands is the position that your character is in. And you don't have to argue with anyone over that position. There's no other peers to confirm this against. You just have the position. However, when you have a position sent over a network, you have a problem, which is that, well, when I'm updating and I'm just pressing W and moving forward, I'm sending position updates to myself every frame and then responding to them every frame, and it's very consistent. And I have a great time. I know the timing of frames more or less, and everything feels good. Physics work right. But when I send it over the network, I have no guarantee of when the messages are received. Not only if they're received in the wrong order, but also, like, are they received really close together or really far away from each other? And so what happens is I'm starting to update the player kind of randomly as I receive messages from the network, and it gets to be very stuttery. And so when you look at why is the avatar stuttering when I move the player over the network, it's because the interpolation is not set up right. So the way that we handle interpolation is that we take the remote player and we delay them a couple of frames, and then we smooth out their position over those frames we delayed. So we'd say, okay, I'm going to listen for the next 3 frames, and I'm going to interpolate the player across those frames, so they're always moving toward their final position, but not just updating it immediately. And the net result is that we get a much smoother player motion and app motion over the network. And interpolation is really the make or break, do or die for like good multiplayer, I think, a lot of the time. So we have a state player, but the state player gets broken up into players who are interpolated and players who are uninterpolated. Interpolated players are remote players. We have to interpolate their position so it's smooth. And in interpolation, we can just kind of, it's synonymous in this case with smoothing, right? So an interpolated player would be any remote player that's sending remote data where we need to smooth it out. Any uninterpolated player would be any local player or NPC where we don't need to smooth it out because we just have the right data. And so we have a player base, a state player which inherits from the player base and adds state binding functions for networking. An interpolated player which adds interpolation functions to the state player, and all of this is around interpolance. And that's all that's in the interpolated player. And then we also have an uninterpolated player which handles a similar kind of interpolation, but it's much simpler. It doesn't do any of the complex smoothing functions, but it does interpolate the actions. Since one action can go into another, there's some handling for that in the uninterpolated player. So then by that logical extension, all local players are uninterpolated players, and therefore the local player class builds on the uninterpolated player. And all remote players are interpolated players, because they all need to be smooth. So if we look at the local player class, it has functionality that is specific to the local player. Some of this stuff actually needs to be moved, honestly, to be shared by by all players. And so we'll probably move name and bio and physics and stuff to be in the state player class or even in the player base class. Because all players should actually have this stuff. But for now, it's in the local player because we haven't had multiplayer and we've been developing local players. So some stuff has made its way into here. But generally, the local player is only responsible for things that only the local player cares about. For example, changing your avatar. If I drag and drop an avatar onto the window, then I want the local player is the only one who really needs to handle that function, right? And then it will propagate to all other players. Hey, my avatar changed. If I want to turn my microphone on, I really only need to do that to a local player, because remote players don't have microphones. They have something else. And if I want to grab an object in the world, same thing. I'm doing that. I'm actually grabbing it on my side, and remote players are seeing the app position update in the world from the actual app updates. Like the world saying, hey, the position of that object just changed, so you should change it. They don't have to see that I'm grabbing it with all the complex grab physics and stuff. And then the local player also has an update avatar function, which we'll probably need to bring over to the remote player, at least some of this too. And mostly this is like, hey, update the sound effects, update the visual effects, like the sonic boom or the nameplate or whatever. Update if I'm swinging at somebody, if I'm actually hitting them and damaging them. Update character behavior is actually, if I'm eating an apple, is my mouth moving for the apple, or is it moving because my mic is on? And it handles those kinds of edge cases to make the mouth move and the character do specific things. Update the interpolation. Even though this is the local player, I do have to interpolate my actions, so I am going to update the interpolation. And then apply player to avatar says, okay, well, I've done all this player stuff. Now I want you to make the avatar make any changes I have to, like to get the mirror set up and anything else set up, and then update the actual avatar itself once I've applied the player stuff to it. And then this sets the, like, is the avatar running, where in the animation state is the hair swinging, and that's all handled by this avatar update. And then character hups are heads ups for like chat. You type a chat and that'll show a hup which shows the character talking. Whoops. So that is the local player. Now the last part of the character controller we have is the remote player. Local player, you know, I'm changing my avatar here. I'm changing worlds, so I need to attach and detach my state between worlds. I'm the local player. The remote player needs a lot less. The remote player is really just saying, hey, like, if you exist, I need you to respond to stuff. So, remote player as the constructor, blah, blah, blah. Main difference is that the remote player prepares an audio worker, and instead of having a microphone and a microphone worker, the local player has an audio worker to handle audio coming over the network, and that will then move the mouth of the remote player and have the audio play out of their player in positionally accurate. And other than that, the main thing that the player does is attach state and detach state. So let's go look at the main difference between our local player and our remote player is in the attach and detach function. In the attach state of the local player here, the local player creates a transaction and sets a bunch of data. So it's actually publishing data to the network. I'm telling the network, hey, my player's player ID is this, and I am here, and I'm looking in this direction, and this is my avatar instance ID. The remote player, I'll scroll down. When the remote player binds, it's actually observing, hey, whenever the position or quaternion change, I want to update my own position and quaternion to move the player. So this is how the player actually moves over the network. And I could say, well, I'm not listening for changes in the player ID or the player name, but I probably should be. And I would probably be doing those here, since those are set on the character controller. So I'd say, like, an example if I wanted to add something here would be like, if, let's see, const, let's see, well, I don't know, let's say, like, let's just do a simple one. If this dot player map dot get player ID does not equal this dot player ID, then we could say, like, console.log player ID changed. That's very unlikely. What would be very likely, it might be like name. So my name changed. And so I can listen for events here. And so I probably wouldn't do this. I would actually say, like, const added removed equals E, and then if added contains, if it contains a name or something like that or whatever. I don't know. E dot changes. I'm not even sure. But this is where I would handle observing player changes. Right now, the implementation is that we're only observing the position and quaternion changes of the player. And even that is broken. So we're going to have to fix that. So the main difference between the two players then you see is that the local player publishes and the remote player listens, observes for state. For the same state. This one's getting this .player map.get position, and this one is setting this .player map.set position. So local player has control over their own avatar. They publish changes to their avatar, to their player, to the network. Remote player listens to the network for changes, displays the final output of those changes, to the user. So that's the main character controller, right? We have remote and local player. They are bound to uninterpolated and interpolated players, which both inherit from state player, which inherits from player base. It seems like a lot, but I think once you understand, like, okay, well, they're inheriting because they each are like a different class of functionality, and that way it really helps to encapsulate certain kinds of complexity inside of a single class, instead of one uber class that has just everything in it. So now we have one last main part to cover for the Webaverse multiplayer, which is the app manager. So all players, remote and local, and the world have an app manager. We would call these application owners. They can take ownership over the app, and while they own the app, they pretty much are responsible for publishing the changes that happen to the app to other users. So all apps in the world, there's two kinds of apps. There are apps, which are objects in the world, and are 3JS objects and have functionality. There are tracked apps. And the tracked app is the representation in the state of the app. And so they're bound together. So we actually bind the tracked app to the state to make any app into a tracked app so that updates happen to it everywhere. You could just have an app floating around, for example, Skybox, and we're not syncing the state of that app, I don't think. I don't think we're syncing the state of it. You know, we don't have any reason to. It's not a tracked app, it's just a thing in the world. But if we have a sword and you pick up that sword, now it has a bunch of state. That state needs to be synced. Who it's hitting, how much damage it just, I don't know, how much durability it has, who owns it, who's wearing it right now. Are they wearing it on their spine, or are they holding it in their hand? These are all like state things that we'll want to have synced. And so the owner of that app is responsible for sending that data back to the network, and then that goes over the network to the remote versions of that app, and that then is applied to the actual app in the world on the remote players. So when I press escape, come on. I thought I had a, oh yeah, I'll do it. A lot of bugs. That's fine. Whoa. I'll just make it here. I just want to see the app state, just kind of bring it all back to what we're actually talking about in the world. This right here is an app. And if I look in my docs, binding, any of these apps are being tracked, I believe, because they are bound, and stuff is happening where if I move any of them, they will move for other players. If I go up here and I take this app and I move it, really need to work on that. Whatever. I can move it around and it would move for other players as well. And that's because it's a bound app. The binding is actually here. You can see it says binding apps, and here's all the bound apps. And so these are being tracked. So in the app manager, every let's say this is the local player or the world. Everyone has this same kind of setup where you construct, you bind events, you bind your apps array. If you are a player, then your apps array is here. It's this player apps, and you can see that I only have one player app bound, which is my avatar. And if I were to grab a sword, I could have two apps bound. So that's all happening here where the state is bound. I'm binding events, which are saying, hey, if a tracked app was added, then we'll handle all of that, of actually adding it to the world and updating it and then initializing it. I'm also adding an event for tracked app removed. If it was removed, we'll unbind it, remove it, destroy it. I guess we're not doing anything if it was imported, and if we're exporting the app, which means we're moving it from me to you, then we'll handle some functionality to like push it to the right app manager and stuff like that. So the main things here are the app manager binds the state, and the state binding is an observe function. And the observe function should happen, we should say, well, if the local player updates something, then we actually want to skip this observer function. We don't want to bind necessarily, like this is what I'm going to look at next, but we don't want to call the observe function on the local player. We only really want observers to trigger on remote players, because the local player should be responsible for changing the state and then sending out those state updates, and the remote player should be responsible for observing and responding to state. What we see here, though, is that, at least right now, all app managers, local and remote, are binding to the state equally and observing. And that might be okay, because probably somewhere in here we're checking for a local player or something like that. But I'll bet you this is probably the source of some of our bugs, is the fact that we're binding and observing in the local. So in Webaverse, always observe remote changes, always publish local changes. The app manager's main job is to bind the state and call and listen to changes to apps. So if I'm, what that actually looks like I have an app, maybe it's a sword, it's added to the world. We call, we say, okay, cool, look, this sword was added. For each sword that was for each thing was added, get the instance ID, look for the app. Did we find the app in the scene yet? If we did, then let's import it, which means let's take the app and let's bind it to state. Instead of remaking a new app and all that, let's take the one we have and we'll bind it. And that's called importing. If we don't have the app yet, we can't find it in our scene, then we will actually create a new one, and we will either get or create a tracked app, which is the tracked reference of data in the document, in the ZJS document store. Or we will we'll either get the one that exists or we'll create it, and then from there we'll add the data onto it for this app that was just added to the world. If the app was deleted from the world, well, we're going to check a couple things. We're going to check if it moved from one user to another. If I deleted the app off of me, but I moved it to you, we traded, then that would actually be a tracked app export. I'm actually exporting the app from me to you. We're going to move its state over. And so instead of just deleting it from the world, we would handle it slightly differently. And so we can validate that by saying, well, another peer owns this app now. It was removed from me, but somebody else owns it. So I'm going to call the functionality to export it to them. And if it wasn't migrated, nobody else owns it, then we're going to remove it entirely from our scene and call this tracked app removed. So that's the main observer function. This is how we handle apps being added and removed from the world, as well as picked up and dropped by players. Is this code gets called. From here, there's obviously a lot of deeper functions. Get or create tracked app, which we'll check if it doesn't exist, we'll create a new one. There's get the peer owner app manager, which checks all the owners and sees if we have one that owns it. Let's see. Then there's these message events, which get handled elsewhere. So we could say, okay, well, this event listener for tracked app export is where we handle the slicing it out of one, slicing it here and pushing it here, right? If we are the source manager where we're exporting it from, let's remove it from our own apps array. If we're the destination manager where we're exporting the app to, then we will add it to our apps array. So all of our state binding and unbinding, adding apps to the world and removing them, literally adding it to the 3JS scene or deleting it from the 3JS scene, all that stuff is handled in the app manager for both local player and remote players and the world and everybody. So to recap quickly, we connect to a world instance which sends us to universe.js. Universe.js. That handles the connect room function, which goes through and binds, the main things it does is it binds the player manager to the state of this player and tells other people that we have created a player and our player ID and our avatar and all that stuff. It binds the world to the network, says, hey, get me all the apps that are in the network server right now and bind them to my world app manager. It binds the local player to the players array and says, okay, listen for changes to the players map, and if any happen for my player, then start responding to them. And then also listen for audio getting sent over the network. So that's the entire connection. Now we've connected. If we look in Webaverse, the other interesting thing is that app.jsx, you see how it says handle URL update, calls the universe stuff. then it starts the Webaverse loop. So the actual loop of Webaverse and the connection and everything happens in the start app right here in app.jsx. And this is where we also bind the inputs, connect the canvas. Inputs would be like, you know, WSD, controllers, stuff like that. And then we actually start our render loop. So we handle URL update, we connect to the room, we start the loop. The render loop handles all updating of the application, physics, networking, everything except for observer functions. The only things that really happen to application state that don't happen in this loop are things that are responding to like an observed state change in an avatar or an app or a player changing. The observer functions are, well, I will go through them really quickly. In the character controller, there is the observe player function, which listens for changes to the position and quaternion and probably later like name and bio and stuff. There is the observe avatar function, which listens for changes to the instance ID of the avatar and calls sync avatar if it changed. And then there is the observe what should be called the observe apps function. Here in the bind state, the observer for apps in our app manager, which observes the changes for apps, and then the last one is observe tracked app observe. So we also observe changes in tracked apps. And so these would specifically be, for now, the changes of position, quaternion, and scale. And that would be any app in the world that changes positions that is a tracked app, like this, responds to this observer function. So those are all the observables. Players can observe, oh, and then, sorry, the last one. I guess there's 5. The observing of the actual players. Player observer function. So we observe changes for players, and we publish from our local player. We observe changes for character controller and the actual character, like the position and movement in the character controller JS, and we publish that from our local player. And we observe application, like app changes, in the app manager. And so in developing multiplayer, I found that most of my time is spent between app manager and character controller. This is where most of the actual functionality that we care about is happening. So from that, I think that's the overview. I'm gonna get some chips, and then I'm gonna get into actually fixing bugs and just going through and trying to fix bugs. So you guys are welcome. We'll probably just hang out and co-program that. But that's been my TED Talk.
That was a great overview.
Awesome.
I enjoyed